Welcome back. So let us now continue our discussion. Okay, so we have this now energy balance, the energy that is going in and the energy that is going out or leaving the system. Okay, so let us recall from our Fourier's law that our Q is equal to K A dt over dx, right? So we have this term, right? So we will gonna use this and substitute this Fourier based from our Fourier's law in our general equation of this balance. Okay, so we will gonna analyze this Q in the specific direction or dimension. Okay, so along X, so let's analyze this Fourier's law along this X direction. So let me copy our illustration, the element. Okay, or maybe let me redraw it. So using the x, y, z axis of this rectangular coordinate system, then we say that we have this x, y, z, right? Sorry. So we have this element, right? Okay. So our qx is this. What color did I use? So I use color yellow, so let me again use the color yellow here. So we have our x. So by analyzing this, then let me relate this general equation based from our Fourier's law. So in terms of this, our qx is, we have the negative k, of course, the property of the material, and then our a, what is our a here? And if we take a look at this, then the energy that is going into the system at the x direction, the area is this part, right? This part. Okay. So this part. Okay. So that is that part. And that part is actually is our, what do we call this? This is our dy, right? And this part here is our dx. Okay, so our area is the dx. I mean dz pala. So this is our dz, right? So our area, if we will gonna consider the q going into the x direction, we have the dz multiplied by dy. So this is now our area, right? And then we have this part. I mean, this is the length, right? So we have dt over dx, because we are talking about this thickness here or along X, right? Okay, so following the same principle, we will gonna do this along X and along Y direction. Okay, so therefore our Q, Y, or going into the system, is that we have this area or we have this interface. Okay, so Q in is that we have the negative K, and then our A is we have the dx multiplied by our dz. So we have dx dz, then our delta t or dt, and our length is this part here, the dy. Okay, and for z, we have negative k, and then our a is this area. Wait lang. So this area. So our QZ is that we have our A is that we have this part which is dy, and we have this part which is dx. So we have dx. Oops. Sorry. So we have dx dy dt over dz. Okay. So all in all, we have this general term for our q in, qx, qy, and qz, right? Okay. So the same principle is we will gonna adopt the same principle for our q leaving this system. Okay. Okay, but before that, let us now rewrite our equation. This. So from here, let me copy this. Copy. Probably. Yan. So this is now our general, and from this general equation, from our energy balance, we can now substitute the values of our Q. So for Qx, we have this term, negative K dz dy dt over dx. Let me take the partial derivative, since we are talking about the individual what they call this, derivatives of this x, y, and z direction. So we have negative k dz dy partial derivative of t with respect to x. And for y and z, so we have k dx dz dt over dy. And for qz, so we have negative k dx dy dt over dz. Okay. All right. So we have now already. I mean, we now have already the values of these Q's. Okay. And for our heat gen, so for our total rate of heat generation in a medium of a certain volume, so we call it G, that, right? And recall that this total heat gen here is the summation, I mean the integral of the uh, heat generation per volume multiply by the certain volume of our medium. So we gonna have the totality of the heat gen of the certain volume. Okay, so our G now can also be expressed as uh, the heat gen for volume, then multiplied by the certain volume of the medium, which is the volume now. By having our illustration, we can express this, the total volume, this total volume of the element as the um, the product of the dx, the dy, and then the dz, right? To solve the volume of this element. Okay, so instead of writing this v, you can now have, oops, you can also write dx, dy, and dz. So our this is our v, right? Okay, so we will gonna use this expression to substitute here in our uh, uh, general equation. Okay, so this is now, I mean, when we substitute this, then from here we can now add this value. Wait lang. So we can add this value to represent this total G. So we have G dot dx, dy, and then dz. Okay. Okay, so we already now have these terms in terms of the different expressions based from our Fourier law and the total heat generation, okay, in a medium. Okay, so okay. So we will gonna continue our remaining equations, this part here, on our next video. So do not forget this expression. We will gonna continue this later. Okay, so see you on our next video.